So, Megan, why don't you get the electronic box out? We can bring it up here. She's going to set it up and see if she can get it to work.
We might have to get him to leave.
Yeah, it tends to not work when I'm in the room. So basically, what she did, we have in this box. This is still very much in progress. We need to do some industrial design. See all the wires. It's all breadboard up. So she's got the Myo armband. Myo armband is about $200, I believe, to purchase. Just on Amazon.
Yeah, the servos inside.
Servos are actuonic servos, same ones that the Ada hand uses. So some things that I liked about the hand. Well, it looks nice. It functions reasonably well. You can play with, you can pick stuff up, play with baby toys. So we do some very rough testing of picking up blocks and sticking them into little hole-shaped things that babies do to learn fine motor skills. Some things that I don't like about this particular thing. This is news to Megan, I think. I think there's problems with the skills that you need to actually put it together. Thinking about the level of skills of majority of enablers, this requires some programming. It's not difficult programming, but that's a barrier right there for a lot of people. It requires some electronics, breadboarding. It requires soldering. And when you start adding all those things up, it becomes a limiting factor. People aren't gonna, it's not going to have much widespread use. Right? So what I'd like to see is maybe some work on not doing so much myoelectrics with the muscle sensing, maybe something more with self-contained kind of gesture recognition. Commercially available prosthetics, things like the e-NABLE, I think you've heard of that. You can do gestures, so trace patterns in the air, something like that. For anybody who knows video games, sure. They do gesture recognition, so kind of building gesture recognition into an Arduino board to control and do different poses that you have an option to do. So the problem that I see with this is, again, it's not.
Now, are all of those challenges because, after all, you're doing the R&D, or because it's intrinsically going to require a bunch of breadboarding to make, the third instance of a given design?
So I think most of the challenge that we're experiencing is it's the first one we've done.
Right.
So once we get better at it, maybe solder a little bit better, get a little bit better cleaning.
One of the ones.
Yeah, right. So open bionics has that. We could buy that. What I'm trying to do is make it so that you don't have to buy anything else.
Can you talk about the muscle sensor band? So
the muscle sensor band, it works very well. It's a commercial product. The thing I like about this is I used a Myoware sensor, which is a little bit cheaper, but it's got the sticky contacts that you have to stick on. You have to get two for the muscle sensing, and then one for kind of sensor. And it's hard to get those positioned just right. And those are disposable, so you constantly have to throw them out, place them. If you get sweaty, that can interfere with the signal. Thinking for kids, they're not going to like ripping it off and putting it back on. So that's one thing I like about this Myo armband. It actually just slides on, and you're good to go. Nothing sticky.
Picks up the signal as well.
Picks up the signal just fine.
If she used the arm, his name, she had it on right now, uses the arm, but then the band slides over a centimeter. Does that pick up different signals, right?
It'll still pick it up. Might be a little straight. It's really nice though because with the armband, you are able to customize it for a person. So right now it's on the default setting, so I can give it to any one of you guys, and I'll be able to kind of get the basic of what's happening with every signal that's being sent, because whether you wave in, you wave out, different muscles are being fired. And so those actually this picks up to sends to my little chip right here. You can customize that, and you do. It takes 5 minutes to run through it, and you do wave in, you do it again, so it sees exactly what yours might look like to calibrate.
It calibrates to you,
Okay.
so you can customize it to.
And so then if it did move, that would eventually go.
You might need to recalibrate just a little bit, but it's very easy
But
to recalibrate.
Okay.
Yeah, and then it's a sync, so like if it slays out here, all I have to do is go right there and then wave out, and then you'll feel a buzz in your arm, so you know that's resynced back up, and then it'll be good to go.
So remember you were saying, while the Meyer band works well and it's easily purchasable on Amazon, you don't like it just because it's $200. And that's
Not just that. So the band itself works well. You can plug it in and control apps on your computer with it. You can control PowerPoint, whatever you want. Where the problems come into play, and this is probably a deficiency of what we can do in our lab. So I should explain. I'm an astrophysicist, so I don't have a lot of electronics experience. I'm kind of teaching myself all this as I go. Megan is a biology major, biochemistry.
Even
So
more
it's-
relevant.
It's not really engineering, and we don't have any engineers there. So that's where I kind of think our perspective is kind of more maybe the average enabler. There's lots of engineers in the enable community. They could get this working probably a little bit easier than me and have some very good advanced soldering, maybe not even advanced soldering skills.
Yeah.
Just better at soldering than we are.
And the coding was nice because the Pope Paraguay code that we used, I used that
Yeah.
framework and adjusted that to the linear actuators instead of a servo, which made the whole process a lot easier. Instead of learning how to code the entire 200 lines, whatever it was, I was able to just put in the degrees from instead of 0 to 90 with a normal servo, I think it's like 0 to 1,000, and that tells you how far it goes in, and I can adjust that if I only want to half close. I only go to 0 is the resting to 500, and then I'll close halfway. And then I was able to put in every finger for every pose I wanted to do. When I make a fist, this will also make a fist when it picks it up when I want it to come down. But if you wanted to have all your fingers closed, you just say index finger close, right? Ring finger close, and denote all of that for it. And then if you want to say make the peace sign, which is one of the poses for it, you say pinky, ring, and thumb close, and the index and middle stay open, and then it'll do that right for me, which is a great resource to have. Doing that, I don't know if it would have been as easy to get off the ground as it was.
So
Yeah.
this
Not-
speaks to
nowhere near as-
Christian's work in Pope Paraguay. Their code is very easy to understand, easy to figure out. That's the other barrier. Soldering everything in there and then flashing the firmware on. You need a custom. You need what was it?
Debugger.
Texas Instruments
And then the way that
debugger
you have
to
it-
get everything put on.
You have to flip it and then redo it and then find the firmware, put it on your computer, put it back up. But then how they have it in the system about how you do it, you actually have to flip it, which was kind of a stop for me for about 2 days. I was like, why isn't this working? And I was like, okay, maybe I should plug it in wrong. I had it right, but how I wanted you to do it was actually opposite of what was said to do. And I was like, okay. Which is one thing I kind of put a basic set of directions on how to do it from step 1 to the final product. Here's how I did it. You know what I hit. This is how you get around that. Should that happen?
And then at some point, I will take her instructions and then I'll run through them. I will adapt them so that I like to think if I can understand it, then any idiot can. So we'll idiot-proof it by sending it through.
But
Yeah,
Eric,
the rocket scientist can do it.
you're not just any idiot.
You get the signal from the item.
Sure. Yeah.
There is two perform.
Yeah.
So are you using the signal?
We're not using anything else. We're just using the most basic thing at this point so far. I do have another student that's working with, instead of using the Bluetooth chip, because I see that as the biggest barrier. Flashing the firmware, getting it to communicate with my armband. So I've got an Arduino That's the Uno. I've got a 101, which has the accelerometer and gyroscope built in. That can recognize gestures. So I've got somebody working on recognizing gestures to control the circles instead. And that's all self-contained. That's all built into the arm. You don't need any contacts with the arm at all. That should just be easier to plug and play and significantly cheaper.
What's nice about this as kind of a toy option is I can have it with the Bluetooth chip and have the arm, and I can walk probably halfway down this hallway and still do my gestures, and it'll pick that up and have it do, which is
So you can play pranks on people.
Yeah. If you lose your hand, it's still a little bit loud, so you can find it.
The bigger problem that we got sensor that for our children. I mean, under 5 years old.
Yeah.
I mean, Colombia, we manage a person with our 5 years. And under 7, 8 years old, it's impossible to fix that.
Yeah.
So we try, we cut the sensor.
Right.
And we try to put away parts, make it smaller. Oh my goodness.
You know what?
We lost 2 biosensors trying to watch out.
Is Thalmic provide? Do they know what you're doing? Will they provide you with any for free?
Yeah, they provide, a person provide 11 pieces of those sensors class. So that is why we take the risk.
Yeah.
To
Yeah.
have and try to research.
Yeah, I know people are trying to put them on different
Yeah.
parts to put them on the shoulder.
You know, Prashant has tried to get myoelectric sensors working for a long time also. And in India, and under the variable and rough conditions, it's a very finicky business, he found. He's eventually come up with an armband with a micro switch, and you twitch your muscles a few times, and that activates it. So, you know, after all, what you've got there are 2 really interesting technologies. One for controlling the motors, and the other for sensing the muscles. And I'm wondering whether it's worth thinking of those as two parallel possibilities. You could go with both, or you could go with, for example, a motorized hand with some kind of mechanical actuation. Have you explored that, Christian?
The most advanced that we have in common, the myoelectric arm with the elbow cord, the mechanical elbow.
Okay.
And we are trying to control the position of the elbow with the gyroscope sensor.
Yeah.
But the way it's working, yes, with the elbow.
Sense the position that it's in.
And that's all. I mean, we are trying to get a signal directly, not from the gesture.
Yeah. The raw data
Directly
from
the sensor, and process that signal to make different.
figure out what it means.
Exactly.
But you have not explored non-myoelectric Yeah. Switches.
Switches.
Yeah.
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 We
Okay.
haven't tried that. So I think that have a lot, huge like more possibilities.
I do too.
So that is why we haven't tried sensor mechanical sensor. At the moment, we have 7 gestures, different gestures, and not from the common sensor. The common sensor are just 5.
Yeah.
We got 2 more. And just getting the signal directly from the mind.
Cool.
So I'm curious. So this is what I expected. I figured Christian would have a lot to fill in here too. It's because I'm standing right here. She did great work.
Yeah, I've done that.
We have videos online all the time. I'm curious. So for processing the raw signal, are you doing that well with just the Arduino to process the gestures and poses? Build stuff to my that works.
That's a lot of programmation. Yeah, that's a lot of work. The thing is that our philosophy is to release the test after the test.
Yeah.
Without a lot of give because in that way, it's like we are not following the research process.
Yeah.
So that's why we haven't released the code.
Sure,
After to test that, like the problematic arm. Actually, I'm gonna release the problematic arm right now because we have more than 3 children with that problem.
Yeah.
So after to test that, we're gonna release the code with all the raw signal and code.
Cool.
So is the idea for Christian Pacific with this type of design is just very necessary to further you get up the arm. You build it out, you don't pass it out. It's better than the shell shoulder elbow. Just has more possibilities. Is that why do you think it's worth pursuing?
Yeah. So the shoulder, whatever.
But why? I mean, not why go down the path? I mean, what's the game?
A higher function. When you start, correct me if I'm wrong. So when you start moving higher up, or even just using body power, it introduces a lot of muscle imbalances. So there's a lot of training that you have to do for that. Myoelectric doesn't have that yet. And you can also get, I believe, higher strength out of it, so you can get better strength and more variety of.
There's little motors.
Like doing the baby toys, and I had no issue picking those up. I even got a water bottle, one of those small half water bottles. We would pick those up. You know, handshake with very good grip strength would be one nice thing. To give a handshake with a body powered prosthetic, you have to bend the arm, and it's a little bit awkward. But this one, as long as you have the muscle, the sensors going down to your muscles, you can do it without moving your arm. With a nice handshake.
So I think Ed was alluding to it. I think the FDA is kind of testing this. They're doing motion capture, people using body powered prosthetics and finding all sorts of strange things they get using the body to get it to actually work. I think what Ed was saying, where you can't use the elbow powered device to pick something off the floor. That's an issue. So with the myoelectric, they have their own problems. You don't get that feedback in your body. That's a good thing because then your muscles don't get exhausted. But then it's a bad thing because you don't have a connection. You can't tell when something's going to happen.
After a while, so they have to try again. But that is not. That is input of inside of the robotic block. So they don't use the arm, so it's normal. And they get tired and the muscle don't work. And the thing is that after application, you have two kinds of muscle. The first one is that it's monoarticular. I don't know if you say that in English. Monoarticular, it's just one link to the bone, and the other is biarticular. That has two links. So the monoarticular muscle is cut that it doesn't work anymore. But the biarticular, that is cut. You can work with that kind of muscle. So you have to figure out what kind of application and what muscle what muscles can work. And that's the advance of the Mayo. So you can get signal from any place. In the other way, with the other kind of sensor, just the advanced technology. I don't know. The brand is from the advanced technology. So you have to search where with the sensor. And that's something that each person don't work in the same way. With that kind of sensor, the only thing that you have to do is just pinch the sensor, and that's all.
So it's worth the cost.
Yeah, exactly.
Very, very adaptable.
Baseline processing. That was my fault. It's like, well, you've got to put sensors in the same place every time. That's impossible, right?
You get it lined up just right. So
process.
when it's working, She'll put it on. She'll do her poses, and then I'll come and I'll put it on. Poses, calibrate it myself.
I had one of his business
It's
class
great.
come in and did a demonstration to them as they pass it off to 2 or 3 of the students, and it switched between them very nicely. Just they did
Very
the
that.
put it
That's
on,
good.
did the sync pose, and they were ready to go.
It's nice, but again, I think the barrier to entry is probably too high for most basic needs. But
We're a better design, and better kit. What if you could charge a $500 price point?
A prosthetic like this with the function it does is about $10,000 in a normal market, which might have a little bit higher functionality, but sometimes that's not always covered by insurance. So I think it'd be very practical for teenagers, for kids that they don't want to invest, that might be broken during play or anything like that.
Particularly in the US and Europe, at a $500 price point, it's not that expensive.
no, but I suspect that the price would drastically increase because with something like this, you're going to have to get FDA involved.
Yep.
Which is
So I think you would
which
need-
raises the question of whether Open Bionics is going great guns these days,
Yes.
and they're basically working on.
They're going through the NHS.
Well, that's right.
Yeah.
And
Trials.
one hopes and one suspects that they're the kind of company that would try to make them available at their lowest price point, given their economies of scale.
Their lowest price point for theirs, I think, is coming in about 10,000.
Today, by the time, what's that?
Right.
That depends on the rate of just someone just agree $5,000, but you have 5 years students around $50,000.
Right.
And if you have a opposite income, well,
Yep.
you can replace the
The risk.
the risk.
Yeah, which this doesn't do.
It depends on the rate
Right.
of movement.
But so
You know-
where do you draw the line? Say tomorrow you guys had this board, like, would you have the right to provide it over there? Like, do you guys know? Like, would you feel comfortable providing it, or do you think that if you provide it, you have these companies come after you?
That's where I'm curious to talk to the FDA. So, yeah, I don't care about companies.
Well, I mean, the
So-
companies you try to sue.
I have some more leeway because I'm working through the university. So I have their legal teams to back me up and go through their approval processes too. They're not going to let me do something if they're going to get sued for it. Just regular volunteer might not want to kind of take over this until we kind of get it through a couple more hurdles.
The questions people are asking speak not to the technology, but to these meta and market issues.
Yeah.
And, there's just a whole range of possible futures that you're contributing to. One of them is that you help drive down the price of the commercial product when it eventually hits the market. Because it's going to be clear that it's going to be possible to do this less and less.
Yeah.
And so maybe they'll learn directly from what you're doing. Maybe the market will simply learn from what you're doing and demand that someone produce a low-cost but FDA-approved device. It's also, and I can tell you, it is an irresistible attraction to future prosthetic and biomedical engineering students.
Oh yeah.
And it's great training for them.
Yeah.
So I personally am sort of, this is just me. It doesn't have to be anyone else. But I think that one of Enable is in a position to capture the market on crude and cheap.
Right.
I think we may own that market. And it's a real contribution because, people need it.
That's the market I like.
Yeah.
I think that's where every engineering class, every engineering university, there are students that want to create myoelectric
That's right.
arms. They want to do this. Engineers want to basically do what you did over the summer.
Yeah.
And this is their summer project. This is
Yeah.
their capstone project. And then they finish it, and then they're gung ho, but then they graduate and they forget about it. So this has been done at not to put you down. This has been done hundreds of times before. People just keep repeating the same thing over and over.
Well, but you know,
we're building on what other people did,
right,
and kind of advancing this.
So we're trying
All
to cut
these-
down the cost as
Yeah.
far as we can with the 3D printing, use of
Keep it simple.
AdaHand, which I really
Yeah.
like because they don't have what Ed touched on, no rubber bands or anything like that, which might be something for him to use in your lab because
Yep.
if you step on it, like it's flexible,
It's
it's
one
not
cell
gonna break.
difference.
Yeah.
Yep.
The provides that and this if it breaks, this
Yeah.
print is not much I give to the arm, but
We can do that in interface.
yeah, it's easy to print, and then you have to break the case and you just put it right back in
Sure.
the spots, and then it's good to go again. It's just really simple. So
congratulations.
So that's what we're trying to capture e-NABLE and keep it simple.
Well,
Nice.
right, while also
Complex, but still
exploring
simple.
the fringe areas where interesting things may emerge.
I think prices will be driven down too with Open Bionics. And
You
you
bet.
heard of Bionics too? Ben,
Yes, we're in touch with him these days. He's trying to figure out. He doesn't have a commercial product or approval yet.
Right.
He's sympathetic to open source, but he's trying to figure out the business issues.
he wants to open source it if he's able to.
Right. Right.
So if you don't know of Ben, he's created a prosthetic. It's fluid based.
For a hydraulic device for his own 4-year-old son. It's this beautiful little baby hand arm. It's adorable.
Because
And it's quite innovative.
there's nothing for that market. For this Ben, is that Ryan?
Questions? Comments?
any
Are you going to
questions,
talk about this
comments?
stuff tomorrow, Christian?
He knows infinitely more than I.
That's okay.
So, question for you guys and you as well. Pulse-wise, couldn't we just say, let's just make it with 3 motors, just have less gestures, but for half the price we get 95% gestures.
So we could take a couple motors out. I would probably do that to not so much for cost, but maybe for weight.
Yeah.
You got to keep it nice and light if you're going to give it to kids.
On the edge, it's something like here, 5 years old. It can control 5 years old.
Right.
But it can learn that. That is starting to learn with the time. And you need another training to manage the control. So with the time, during the time that they are growing, you can and get more just.
Yeah, I'd like to put in a plug to the future biomedical engineers ages, 10 to 16. Thank you. I do think there's real value, and it hasn't been explored because it's not as sexy to the university students, in a 1-motor or 2-motor adaptation of probably a simple enabled device. We've seen a 1-motor arm that will lift and lower the arm if you don't have an elbow. That could be huge, but it's only been done once that I know of as a drawbridge arm. I think that's a really good student project. Similarly, another motor to open and close a gripper hand or an osprey hand or something is really worth exploring. Whether it's myoelectrically activated or activated in some other way. There are much simpler that are unexplored because they're not as super robust and simple as the e-NABLE hands, and they're not as technically challenging to the university students as the myoelectrics, which means it's a really good opportunity for junior engineers to explore, in my opinion. Yes? The limbitless arm. That's right. Yeah. Limbitless.
So that is my understanding is that it's a single motor, so it's fully 1 motion.
I guess that's right.
Those are open, but I'm not sure. Are y'all aware?
I believe they've got the contact sensors. The stick sensors.
I'm not aware.
I don't know what the
they
costs
share
are.
Not
They
not
were
really in touch with them lately, so I don't know.
open source for a bit and then stopped.
I don't know how the I don't know what is the name, the sensor here.
The Myo armband.
Or the other one. Stick, the stick thing.
Oh, yeah, Myoware, I think.
The muscle sensor.
Yeah.
The name is muscle sensor.
Yeah.
And it has a sticks. And that is the cost in Colombia is high. I don't know if the cost here in
It's about $30.
That is why we choose to work with the Myoelectric, with the Myo so that way we don't have to
Mm-hmm.
buy a bag of this kind of stitches.
I know as our audience is beginning to wear out.
846.
Is there anything next on our agenda?
We have nothing else on our agenda.
Okay. And what?
Well, actually, I don't know.
The agenda is okay.
Did
Maria sent a new agenda.
so the latest agenda I have, I might recall. I don't recall if Christian or was Christian scheduled. Were you scheduled to talk today, Christian?
No.
Maria